Alright, you guys, Unit 4, Polynomial and Rational Functions. Okay, a polynomial function. A polynomial is a function of the form f of x equals a sub n x to the n power plus a sub n minus 1 times x to the n minus 1 power plus etc. a1 x to the first power plus some number. So basically, let me write an example. So this would be an example of a polynomial. If I had 2x cubed plus 4x squared minus 5x plus 16, something like that. Okay, so all of these a terms are the coefficients, and all of these n terms are the powers. Okay, that's just an example. There's a million different kinds of polynomials out there. Alright, so for our first example, let me go back to blue. Determine which of the following are polynomial, or which of the following are polynomial functions. For those that are, state the degree. For those that are not, tell why not. Okay, so we're given a bunch of these. For A, we have 2x minus 3x, or sorry, 2 minus 3x to the fourth power. This is a polynomial. The degree is whatever the highest power is. Okay? For B, g is not a polynomial function because the square root of x can also be written like this, x to the 1/2 power. So the variable x is raised to the 1/2 power, which is not a non-negative integer. In order to have a polynomial, all of these powers must be non-negative integers. I'll write that down here. Alright, so all the a's, where's my little cursor? There it is. All the a's, or the coefficients, are real numbers, and n is a non-negative integer. Okay, so no, because 1/2 is not an integer. Okay, for part C, h is not a polynomial function. It is the ratio of two polynomials, and the polynomial in the denominator is of positive degree. That means that if I were to switch this to the top, I would have to make the degree of this whole thing negative. Remember, anytime you have an x on the bottom, when you switch it to the top, it becomes negative. And we already said that n has to be a non-negative integer. So if I were to take this and switch it to the top, it would change to negative. So, no, because polynomial on the bottom is positive. Okay. For part D, f is the zero polynomial function. It is not assigned a degree. So it is a polynomial function, but there is no degree. Okay? For g, g is a non-zero constant function. It is a polynomial, and it has a degree of 0 because if you imagine, this is the same thing as 8x to the 0 power, because anything to the 0 power is 1. So, yes, degree of 0. Alright, now this one, if I were to FOIL this out and then distribute the negative 3x cubed, I would get some regular polynomial. So this is a polynomial function. If you guys can kind of tell, if you're not really sure, you can always just multiply everything out, FOIL this, and then distribute this. But you should be able to see that if I were to FOIL this, I'm going to get x squared plus something else, blah, blah, blah. And then if I were to distribute this, sorry, I have a little bit of cold, I'm going to end up with negative 2x to the 5th power plus whatever. So the first term, or the term with the highest power, is going to be a 5. So the degree is going to be 5. Now once again, if you can't see that, you can always just multiply it out, do it the long way. You'll get the same answer. But there's a little bit of a shortcut if you can see it. Alright. Power function of degree. Alright, a power function of degree n is a monomial of the form f of x equals ax to the n power, where a is a real number not equal to 0, and n is positive and it's an integer. Okay? So, let me write out some examples. Change colors here. So, 3x would be an example, or negative 5x squared, or 8x cubed, or negative 5x to the fourth, anything like this. These would be power functions of a certain degree. Okay? Alright. Power functions with even integers and odd integers are going to have different properties. So let me list them out and then we'll discuss them. Alright, some properties of power functions. When you have an even integer, so if you have x squared, x to the fourth, x to the sixth, something like that, you're going to have a graph that's symmetric with respect to the y-axis. Remember, WRT stands for with respect to. The domain is going to be all real numbers, and the range is going to be the set of non-negative real numbers, so from 0 on to infinity. The graph will always contain 0, 0, 1, 1, and negative 1, 1. Also, this is, I'm just going to write out a description, but it'll make more sense when we do an example. As n increases, the graph becomes more and more vertical, so when you have like x to the 6th, x to the 8th, x to the 10th, as n gets bigger, the graph is going to stretch, and you'll see it's going to become more and more vertical. But closer in between negative 1 and 1, you'll see that it actually flattens out a little bit, so it becomes kind of like a box, or like kind of box shaped. And I'll do an example of that in just a sec. When you have an odd integer, you're going to have a graph that's symmetric with respect to the origin. The domain and the range will both be the set of all real numbers, and it will contain 0, 0, 1, 1, and negative 1, negative 1. And the same thing. Okay? Alright, let's do an example. 1 minus x to the 5th. This is going to be an odd function. And I'm going to rewrite it. Where's my cursor? I'm going to rewrite it like this. We've got negative x to the 5th plus 1. Okay, so I'm just going to sketch a graph real quick. You can use your calculators for this. If you graph this on your calculator, you'll see that it looks an awful lot like x to the 3rd power, except it's flipped because it's negative. It's shifted 1 up because we're adding 1. And if you were to compare the graphs, this is a little bit more stretched than x cubed. My drawing doesn't look that way, but if you look at your calculator, it is a little bit more vertical. Okay? Alright. Let's try this one. Alright, example 3. Graph f of x equals 1/2 x minus 1 to the 4th power. Alright, I'll just go ahead and sketch a graph. Alright, the graph looks something kind of like this. I subtracted 1 inside the parentheses, so it moved to the right. It's to the 4th power, so it's U-shaped, and the 1/2 causes it to compress. Alright, you guys go ahead and try the U-try problems. There are 2 of them. Alright, real zeros. Let me write out this definition. Alright, real zeros. If f is a function and r is a real number for which f of r equals 0, then r is called a real zero of f. So basically, if you take a function and you set it equal to 0, and you solve for x or whatever the variable is, and you get some number r, that r is called a quote-unquote real zero. Okay? There are some other ways you can say this. Other than saying r is a real zero of the function f, you could say r is an x-intercept of the graph of f. You could say x minus r is a factor of f. So if you were to factor this polynomial, x minus r would be one of the factors. Or r is a solution to the equation when you set it equal to 0. Any of these things mean basically the same thing. Alright, let's save the example 4 for the next video. Alright.